Hello everyone. Uh, Welcome for the next session on Algebra, Maxima and Minima. So today we'll be looking at problems where we have some kind of constraints and we have to either minimize or maximize some uh, expression. So a lot of different variety of problems are there on Maxima and Minima. Not a particular single variety is there. And questions are regularly asked on this. So we'll have more than one session on this. Let's see what kind of questions are coming. Again, it's a mix of previous year questions and some of the other questions that I think are relevant to the kind of pattern of the paper. All right. So let's see. Here we go. Now, so this is a very regular kind of a feature where some kind of a constraint is there on some variables and we have to minimize or maximize something. So A, B, C, D are distinct natural numbers whose sum is 21. So one thing is for sure that the sum is fixed and equals 21 of four variables. Based on that, we have to find both the maximum as well as the minimum possibility of the product of these four variables, right? Sum is constant and product has to be both maximized and minimized. Now, the core concept on this question is that when sum of variables is fixed, constant, then their product is maximized when the variables are equal to each other. All right. So A plus B plus C plus D sum is 21. Now, look at this thing that they are distinct. So I just said for maximization, we should make the variables equal to each other, but that is not allowed. However, for maximization, if we were not having this constraint of distinct natural numbers, then we would have said each number should have been equal to each other. So 21 by 4, which is 5.25, should have been the value. Now, so we can't take that value, but then if that is not possible or that is not allowed, the best option would be to be as close, that the variable should be as close as possible in the range of that 5.25 figure. Now these are natural numbers, they can't be decimals also. So we have to take care of both the things. They are natural numbers, they're distinct. So in the range of 5, right? Now, so can I say 5555 is 21? Sorry, 5555 is 20. So 5556 would be 21. Now I have satisfied the integer constraint, but not the distinct condition. I need to make them distinct. What can I do? Obviously, something should be decreased, another should be increased, right? I can't have 3 5s. Let me make this 5. So I'm trying to make it as equal as possible. Now let me make this 5 as 4. Okay, but that will also not serve the purpose because, okay, 1 5 is 4, but then if I increase this 5 to 6, then 6 would repeat. I will have 4 5 6 6, still not satisfied, but I'm gradually reaching there. One more step is required. So now I have two sixes, so I need to further. Now if I can't decrease 5, because then I would have 4 plus 4, so I should decrease 4 only, isn't it? So if I decrease 4 by 1 3, then I can increase this 6 by 7, and yes, then it will become distinct. So 3 5 6 7, can I say that is the most optimum scenario in which I have 4 distinct natural numbers? It can't get better than this. So this is the combination which would maximize the product. It can't get better than this. 5 6 7 are consecutive numbers. 3 is just too short than 5. So therefore, the maximum of the product is the product of these numbers, which is 3 5 6 7. So 3 into 5, 15 into 6, 90 into 7, that is 630. That is the maximum product. Now, what about the minimum? So that is the other extreme case, right? Variables are as equal as possible, maximum product. Variables are as far away from each other as possible, minimum product, right? So it is about the extreme scenario. It is about the extreme possibility, right? So for the other extreme, again, I have my a plus b plus c plus d as 21. But now keeping the numbers as far away from each other as possible means some of the numbers are very small, some of the other numbers are very large. So what should I do to minimize the product? Now, if I keep the numbers as small as possible, all of them, that is one possibility. Or if I keep all of the numbers very small and one number is very large, that is another possibility. So let's try both, right? If I keep the numbers very small, then 1, 2, 3, okay, the smallest natural numbers, okay. So this accounts for a sum of 6 in these three numbers. Then the fourth number can be kept as the remaining value, which is 21 minus 6, 15, right? This seems to be the most optimum way that the numbers are as far away from each other as possible, right? So therefore, uh, for this, the least product will be obtained. Once again, minimum product, variables should be as far away from each other. Sum is constant. One variable, keep it as large as possible, the others as small as possible. As small as possible, numbers, distinct numbers, natural numbers 1, 2, 3. Three of them, smallest distinct natural numbers 1, 2, 3. The remaining 15 goes to the fourth variable. The minimum product, therefore, is the product of these four, which is 1 into 2 into 3, 6 into 15, 90. So the required answer is 630. The question is asking for the difference. The maximum minimum possible value differ by how much? That is 540. 630 minus 90. All right. So something to be learned here. Sum is constant. Product has to be maximized or minimized. What we should do. Variables as equal as possible. That will maximize the product. Variables as far away from each other as possible. It will minimize the product. All right. Now, let's see the next one. Okay, now this is another variety of problem in which a kind of mathematical expression is there, and that has to be maximized or minimized based on the given uh, range of the variables, right? We have x, y, z, three variables whose range are respectively given -4 to 2, -4 to -1, and -2 to 1. Then we have to find the difference between the maximum and the minimum possible value of this expression, which is x into y square into z cube, right? So what should be the thought process on this kind of, I would say, optimization? We have to both maximize and minimize this, right? So to maximize the number, the product, we should be thinking of taking the highest possible magnitude of the variables, and obviously we should keep the product eventually to be positive, right? We should avoid getting a negative value, right? Now the numbers are going in the negative range, right? Now if you're thinking that okay, I should take x as 2, right, to maximize this product, just rethink again. Why? Because -4 is higher in magnitude than 2. The magnitude is 4. What I'm trying to say, that if we take x as 2, then we are limited to a very small magnitude, okay? So you might be thinking, okay, why am I taking -4, a negative value? We want a positive product. But the thing is that we also have the option of choosing a negative value for another number. Minus into minus is positive. So you see, y square is for sure positive. If x and z both are negative, then x into z cube will eventually be positive. So why not to do that, which is take x as -4. And since z is also going in the negative range, and you can again see that the higher magnitude is on the negative side, so take z as -2. right? And why obviously minus 4? Because eventually the perfect square will remove the minus sign. So x being minus 4, y being also minus 4, and z being minus 2, that will optimize this product to its maximum possibility, right? Because eventually we are getting a positive sign. Also, we have kept the numbers of as high magnitude as possible. So therefore, all the minuses cancel and we get 4 into 4 square 16 into 2 cube 8, right? This minus goes off. This minus into minus also becomes positive. So this is coming to be 512. 4 into 16, 64 into 8, 512, right? So understanding the thought process, how it is different, why the trick is not to choose the positive value, but instead also look at the negative value. Maybe you can get a higher magnitude even despite of taking negatives, right? Because negative into negative can become positive. Likewise, now let's think of the other thing. We have to also minimize and then only we can answer, because we have to take the difference. Okay. Now what? Now obviously this time we would want to have a minus sign. Y square will always be positive. So x and z should be of opposite sign. Either keep x as positive, y as negative, or other way around. X as positive, y as negative. Now, if I keep x as positive, which is 2, y obviously I would keep as minus 4 only to maximize the magnitude. You see, to minimize a value, we should keep the sign negative and magnitude high. So y we would take as minus 4 again, right? And z, so this was positive. This would be, we would take as negative z minus 2 cube. So this becomes with a minus sign 2 into 4 square 16 and 2 cube 8, which is coming to be 16 into 8, 120 into 2, 256 with a minus sign, right? Now, we also could have thought of keeping x as negative and y as positive. But you see, that would not give us a better output. Because if I keep x as negative, which is minus 4, this is still minus 4, and I keep z as positive, which is 1, you see we are doing the cube on this number. So 1 cube is very small, so that does not help us. Eventually we don't get a very high magnitude. We only get 4 into 4 square, which is only 64. So this is not a good, this is not a better outcome. This is a better outcome. This is the minimum value that we can get. So I compared both the possibilities, you know, any whichever could have given us a better result, we chose that. So the difference that we are requiring becomes 512 minus of minus 256. We have to take the difference. So 512 plus 256, which is 768. That is the required difference. Okay. So minimization, maximization of an expression based on the range of variables. That is another style of maxima minima problems. All right. Now let's see what more we can have. Third problem. Okay. Now look at this. Let fx equals 2 raised to power x times 2 raised to power 1 by x. Then which of the following values can this function never take? Now, first of all, we can simplify this function in as a single function of a power of 2, right? We can add the powers. So we can write this as 2 raised to power of x plus 1 by x. Now, so x plus 1 by x is a function which for which we should know its minimum maximum value, right? For x being positive, this function takes its minimum value at x equal to 1, and that minimum value is obviously 1 plus 1 by 1, which is 2. For every other value of x except 1, it is always greater than this value, right? So for positive values of x, x plus 1 by x is greater than or equal to 2. Now you can see that the options, all of them are less than 1, and a value of less than 1 for 2 raised to power something can only be obtained if the power is negative, right? So definitely we are analyzing this function when the power is negative. So for negative values of x, in a very similar manner, at x equal to -1, the function takes its maximum value, right? For x equal to -1, the value becomes -2. And for any other value of x, which is negative, the value is less than -2, right? For example, let's check at x equal to -2. The value becomes -2 and plus -1/2, which is -2.5. So it is less than equal to -2. So this whole question is revolving around the maximization of this function, which is x plus 1 by x. Eventually, this function is greater than equal to 2 in magnitude. Either that is greater than equal to 2 or less than equal to -2. So can I say for negative values of x, what about this function? So can I say that the maximum value of this function will occur at x equal to -1, right? So f of -1 becomes 2 raised to power -2, which is obviously 1 over 4, right? And this value of the function, which is 1 by 4, is the maximum value of the function in the range when the function takes values less than 1, right? For x negative, can I say fx is always going to be less than 1? And actually, because 2 raised to power 0 is 1, right? But actually x plus 1 by x is never equal to 0. It can never be equal to -1, -1.99. It can be at the most -2. So eventually my fx can be at the most 1 by 4. So it cannot be 1 by 3. And that is the answer, right? This function can never take the value which is 1 by 3, because for that x needs to be fx, which is x plus 1 by x, needs to be something more than -2, which is not possible. All right, so this was this one on the range of x, this function x plus 1 by x. All right, ready for the next one? Let's see. Now here we extend the concept understood in the previous problem. For x greater than 0, let fx equals 4x plus 16x square plus 9 over x plus 81 over x square. Then the question asks for the minimum possible value of f of x. Okay. Now we should rewrite this function such that 4x and 9 by x can be taken together as a combined term, and likewise 16x square plus 81 by x square can be taken together. Now you can clearly see that 4x the whole square is 16x square, 9 by x the whole square is 81 by x square. So there is definitely some kind of interrelationship that we can make over here. What I'm trying to say, I can express this second term in bracket in terms of the previous term. Means if I do the whole square on this first term, I'll get these two terms, and some adjustment has to be done, right? Because a plus b whole square, a square plus b square will match, but 2ab extra term will come. So what I'm saying, this is 4x plus 9 by x, and this term can be expressed as, let's say 4x plus 9 by x the whole square. So that will give me 16x square, 81 by x square, plus an extra term which is 2 into 4x into 9 by x, which is 72. So that 72 was not there. So I have to subtract that 72 to do the adjustment. Perfect. Now, so I can just say this fx is kind of this function which is t plus t square minus 72, where t is this expression 4x plus 9 over x, right? So we have to basically minimize this expression t, 4x plus 9 by x, right? Now we will apply the very famous AMGM inequality, right? Whenever we have this kind of expression, we can apply the arithmetic mean geometric mean inequality, which states that arithmetic mean of positive numbers is always greater than equal to their geometric mean. In fact, the result of x plus 1 by x being greater than equal to 2 also comes from the similar thing. So you see, this is just very similar expression as 4x plus 9 by x, as x plus 1 by x, except for we have some coefficients 4 and 9. So AMGM inequality tells us that 4x, so applying it on 4x and 9 by x, so the arithmetic mean of these two things, which is that the sum by 2 is greater than equal to the geometric mean, which means the square root of their product. So 4x into 9 by x, x cancels. This is a constant, which is 9 into 4, 36, square root of that 6, right? So can I say 4x plus 9 over x is greater than equal to 2 of 2 into 6, which is 12? So we can definitely come back over here and say that since t, this is the max, this is the minimum value of t, right? This is the minimum value of t that we have obtained. And you know that this occurs at that value of x when 4x equals 9 by x, right? This value of 12 occurs when 4x and 9 by x are equal to each other, or x square is 9 by 4 or x is 3 by 2. So you can check that when we put x equal to 3 by 2 over here, we get 4 into 3 by 2, 6, plus 9 over 3 by 2, 6, 6 plus 6, 12. That is the idea of the AMGM inequality. So fx, the minimum value of that becomes 12. So putting t, the minimum value is 12, plus 12 square, 144, minus 72, which is 72 plus 12, 84, right? Okay. So AMGM inequality, based on that, this question was there. All right, let's see some previous year questions as well. CAT 2020. This came for real x. The question asked for the maximum possible value of this expression, which is x over the square root of 1 plus x power 4. Options are half, 1, 1 by root 2, 1 by root 3. Now, what's the idea? This is very similar to what we have just discussed. Just a slight manipulation is required. Now look at this. We have to maximize this. Obviously, we will keep it as a positive number. X we would keep as positive, and all the options are also obviously positive. Can I restate this expression as, so what I'm doing, I'm dividing by x, the numerator and denominator, I'm dividing by x, or you can say I'm taking x in the denominator. So it becomes 1 over, so 1 over the square root of, so x goes, here also I'm dividing by x. Inside the square root, I'll be dividing with x square. So x power 4 by x square, which is x square, plus 1 by x square. I can clearly say that this expression basically is this. And now this term x square plus 1 by x square looks very similar to the thing which is x plus 1 by x. It is just the square of that minus 2, right? So again, we can apply the AMGM inequality over here and say that the minimum value of this expression can be obtained by saying that the AM of these two terms, by which is this by 2, is greater than equal to the square root of their product, which is x square into 1 by x square, 1. So x square plus 1 by x square, this is 1, over 2 is greater than equal to 1. So x square plus 1 by x square is greater than equal to 2, right? Which occurs, this minimum value of 2 occurs at obviously x equal to 1. So putting that, the minimum value of, so this is the x square plus 1 by x square, this is the minimum value of that expression. So since it is the actual function is the reciprocal of that, so the maximum value of this expression occurs at this same value, which is 1 over root 2 is the required maximization, right? Smaller the denominator, higher the value. So smallest minimum possibility of the denominator is root 2. Hence the answer is 1 over root 2. All right. So You just had to sometimes manipulate the expression. That is the idea. All right. Another one, another recent CAT problem, CAT 21. Let's see. Now, there's a mixed question with some mixed ideas. Some quadratic is also there, and then some optimization has to be done. Minimization has to be done. Least possibility of this expression. Let k be the largest integer such that this quadratic has no real roots. Now, what is the condition for no real roots? The discriminant should be negative. The discriminant, which is b square minus 4ac, right? Now, first of all, this quadratic is not right now written in the standard notation. So first of all, because there is x minus 1 whole square. So first of all, we should write it in the standard notation, which means that just expand this. X square minus 2x plus 1, x minus 1 whole square, plus 2kx plus 11 equals 0. So x square and 2k minus 2x, right? Combining the terms of coefficient of x. So can I say 2k minus 2 or 2 times k minus 1 of x plus 12 equals 0. Now I have the standard form. Now we can apply the condition that the discriminant is negative. So discriminant is whole square of this 2 into k minus 1. So 4 times of k minus 1 square minus 4 into 12 is negative. 4 can be cancelled and we can say k minus 1 the whole square is less than 12, right? K is the largest integer to satisfy this condition. K minus 1 the whole square is less than 12. For the largest integer, we will obviously choose the positive values and not the negative values. So a number k minus 1 the square is less than 12. 3 square equals 9 is less than 12. 4 square equals 16 is more than 12. So this expression k minus 1 can be at the most equal to 3, right? K minus 1 can be at the most, at the maximum equal to 3, or k can be at the most equal to 4. So first of all, the question gives us a quadratic, tells us it has no roots. From that we get a inequality, and then we maximize the value of k first of all. Then the question, so this is a two-layer problem, right? First you come to this, then you come to say that, okay, y is a positive real number. Now the variable is y in this expression. We have to take the least possibility of this expression, k over 4y plus 9y. K equals 4. So this is a function which is in terms of y. Let's call this expression e. E equals k. K is 4. 4 over 4y. So 4 cancels plus 9y. Or this expression is 1 over y plus 9y. Again, this is in that form only. Again, this expression is in the form something plus 1 over something kind of thing. So we can apply our AMGM inequality, right? So 1 over y plus 9y over 2 is greater than equal to the square root of the product. 1 over y into 9y. Y cancels. This is square root of 9, which is 3. So 1 over y plus 9y is therefore at the least 2 into 3, 6. And this value of 6 occurs. Nobody's asking that. I'm just saying that this value of 6 occurs when 1 by y equals 9y, or y 1, or basically AMG inequality says that the equality holds when the expressions are equal to each other. So this value of 6 occurs when 1 by y equals 9y. Y is, remember, positive. So y square is coming to be 1 by 9, or y is coming to be 3, right? From here we are getting y square is 1 by 9 or y is 1 by 3. Since y is positive, so we will take the positive value, not the negative value, right? All right. So you can see how questions are there across, multiple concepts, right? First a quadratic, then its roots are not real. Then we identify k. Then we come to this expression and then we minimize it. All right. Let's see one more problem, one last problem for this session. Let's conclude with this question. I'm concluding with a very relevant problem. It came in ZAT, and this kind of questions are again can look like a bit of hit and trial. The kind of question I took as the second problem, if you can remember, x, y square, z cube, something on those terms, where you have some range of variables, right? And you have to maximize or minimize some expression. So this is a very good problem, I would say. ABC are integers, and mod A is not equal to mod B is not equal to mod C. And ABC, each of these three variables lie in the range from -10 to +10. Lot of things to digest. Integers not equal in magnitude, in the range of -10 to +10. All the three variables, the range is same, but they are having this constraint of not just being distinct, but distinct in terms of magnitude also. So I can't have A as 10 and then B as -10. That is also not allowed. What will be the maximum possible value of this expression, which is their product A into B into C minus their sum? We have to maximize this. Okay, how do we think on this? We have a product. Obviously, we will want to keep the numbers as high as possible, and they need to be distinct. So one line of thought could be, okay, you can go up to 10 and you have to keep them distinct. Let's keep A as 10, then B as the next integer, which is 9, and C as 8. They could take these three values in any order because the expression is symmetric, but any order, 10, 9, 8. Now, the challenge or the thing is that you're also subtracting the sum of these three variables, right? So you don't want to subtract a high value. So, but you have taken the numbers as high as possible to maximize the product. So there's a contradiction over here, right? You want to take high magnitude of variables, and you must. Only then A into B into C will be high. But then again, you're subtracting the sum. Again, you're subtracting a high value. Can you do something better than this? By the way, just call this expression as E, and one thought could be, okay, E takes the value of 10 into 9 into 8, which is 720. When I'm choosing these combination, 10, 9, 8, so product 9 into 8, 72 into 10, 720, minus 9 plus 8, 17 plus 10, 27. This is 693. It is also there in the options. And but there are some other options also which are a bit larger than that. So the question options are making me think, do I have something better? Can I do better than this? So think about this. Your product can never exceed 720. Okay, but can you keep the product constant? Means let's try to keep the product as 720 only. Despite of that, A plus B plus C, don't want to keep. You don't want to subtract a high number. A very small manipulation is required. The knowledge that -1 into -1 is +1. A very small manipulation, and this is the hint. If you can think on this, -1 into -1 is +1. What I'm trying to say? What I'm trying to say, instead of subtracting a positive number, subtract a negative number. Instead of removing something, you will add back something. So what if you keep two of the numbers as negative with the same magnitude? Let's say A is -10 and B is -9. You keep C as 8 as it is. Your product is still 720. But now you're going to subtract a negative number, and your product, your eventual expression will be much. In fact, it will be more than 720, isn't it? So what does it become? Still -10 into -9 into 8 is still 720. But what you're subtracting? Minus of the sum of these. -10, -9, -19 plus 8. -19 plus 8 is -11. 720 minus -11 is 731. That's the answer staring down to us, which is option See, isn't it wonderful? So even algebra makes you think, right? It's not plain dry variable based analysis. It is a lot of thinking, right? If you enjoy, I mean, you should enjoy this, right? Algebra is enjoyable if you start thinking with variables. That's my motive. That's my message. So I hope this was interesting, and I have kept both questions, and we'll continue this. We'll have one more session. So stay tuned for my next session, which will be again sometime in this week. All right. So stay in touch, stay connected. Uh, Ask me anything. I'm there. Reach out to me on the message chat box. Right. So yeah, one very important announcement. Race to 99 workshop is going to happen very soon, August 2nd and 3rd. The dates are coming very near. So a must to attend event, I would say. Uh, this is the session plan, test taking strategies, VRC, Quant, DLR, Cracker, and way forward. Right. So we hope to see you in those sessions to again amp up uh, your readiness for the exam. So thank you so much, and I'll see you very soon. Thank you everyone. Stay in touch, stay connected, and all the best.